Today we will discuss about optimization of sphere and Rastrigin problem using hill climb search algorithm. Here the dimension is 8 is given. Let us see how we will solve this problem. So first of all we have to understand the syntax for hill climbing function. The first argument is PAR, initial solution, okay, and Fn is our objective function. In this case it is sphere and Rastrigin. And CHANG, it is a change function required to generate next solution. Okay, without change function we cannot generate new value. Okay, always we have to generate new value from old value. For that you require some change function, and then lower variable, it represents a vector of lower range of values, upper represents vector of upper range values, and the control is a list actually containing control parameters. That means how many number of iterations you want, and what is the frequency of monitoring information, all these things. That means we have to define the control list, okay, and then finally type, whether we want min or maximization. The next step here is import the hill climb function. After that implement the Rastrigin function. Actually the implementation is already discussed in the previous videos, so the implementation is given directly. And then finally next parameter, what is the dimension? Here in our question the dimension is 8 is given. Okay, d is equal to 8, and then you have to define the initial position, initial solution. So initial solution is 0 0 0. This is the initial solution we want to start searching process. So this REP function, it will give you a column vector of dimension d, okay, and C is a control. I already told you, control list. So in that we have to define, I want 10 iterations, so I will define max height is equal to 10, and then report parameter as 1, and then finally our change function. You can see the change function. In this change function you have to define the function which accepts 3 arguments. So what is the initial solution, what is the lower range and upper range of variables, it depends upon the problem. Okay, and then that's it. So once it is over, we can start the implementation of change algorithm, change function. So the change function, here we will mainly use the normal distribution with mean 0 and 1 of dimension d. This is called the step change. So you have to add this function to the old value. So this function, what it will do means, it will accept the old value PAR. For that PAR, that is old value, some change is added, that is given as the sample, that is a sample from normal distribution. Okay, so this will be added here, PAR plus step value, it gives the new PAR1. Now again you have to check, you cannot simply return the value. Why? Because the computed value, it should be within the range of lower to upper. Okay, so if the new value is less than lower, you have to return the lower value. Okay, if the PAR1 it is greater than the upper value, then you have to return the upper. Okay, upper value. So that means we are clipping the min and max values. That you need to understand. Okay, otherwise if these two conditions are failed means That means if this value is within the limits of lower and upper, you can directly return the function as it is. So all these statements we have written in a single statement. So after defining, you can see the PAR initial solution Fn, that means objective function. This is our objective function, this is our initial solution, and the control list parameters, and then the change function. So this change function, what it will do means, if you give old value and specify the upper and lower range, means it will give the new value within the lower and upper value. So that is a job. So after defining all these things, you have to pass to the hill climbing algorithm. So initial solution yes, Rastrigin function we have defined here, and then the change function we have defined here, and then lower vector, and then upper vector. Upper vector means we have to find the values in between 0 to 1. Are you understanding? 0 to 1. And then control parameters, and then type. We want maximization or minimization. So if you see our program, our question is we have to find the minimum or maximum value where x is a real value vector. So for this we have added this statement. So if we want real valued vector, means we should not round this, we need not have that statement. Say for example, in some cases the application requires that we need binary values or discrete values. In such a case we have to use this function. That step should be it should be discrete, so it should be rounded off. So we have added a condition. So since it is a real valued vector, so you have to write false here. If you want discrete values, means you have to put true here. Okay, so we have put false here. That means this step will not be executed, and then you can execute this one. Okay, so we want only the discrete values, integer values only. Okay, if I want, you can see, if you want real values, means you have to put false. Actually you need not put this statement also for Rastrigin. So now you can execute this statement, Control S. Okay, let us see, Control A. You can see we got the best solution at this. So that means this is the optimum solution vector and its corresponding evaluation value. Now you will understand. Okay, for this solution vector, this is the maximum value. So if I want the x as a discrete vector, means you can remove this statement. Okay, we will see in the next video. Okay, it depends upon the problem. You can see in our case x is a real value vector, so there is no need for rounding this function, so I removed this. So fortunately we got this as a best value. Okay, this is the optimum solution and this is the evaluated value. Okay, at this solution vector you will get maximum value. Okay, so please implement this function once again. Call the library, implement the Rastrigin function, and then the initial solution, and then set the control parameters, define the change function. Here we have implemented the change function with the help of normal distribution function, and finally we are passing to the hill climbing function. Let us execute. After executing that, this is the value we got. Okay, thank you students. Welcome students. Today we will discuss about how to find the min or maximum value for R-sphere function using hill climbing algorithm. So for hill climbing algorithm, we have to implement the sphere objective function, which is given like this, and then initialize the solution with the zeros of dimension d, and then define the control list parameters with this statement. Here you can set the number of parameters, and then define the objective function. This is not objective function, step change function with the help of a normal distribution. Okay, so this function, if you give the old value, it will return new value. That new value, it will be in the between lower and upper. Okay, so we want to find the real values, so this statement is not necessary, so you can comment it out. And then you can pass all these things to the hill climbing algorithm. Yes, sphere, change function, lower vector, upper vector, all these things. And then let us see how it executes. So for R sphere function, we got for this solution, this is the maximum value you got. Okay, so we have implemented the initial solution, we passed it, and then sphere objective function, the change function, it is defined with the help of the normal distribution function, upper range of vectors, lower range of vectors, upper range of vectors, and then control parameters, and then the type. Okay, thank you.